All right, guys, notes for today are 2.6. This is the remainder theorem. It's a quick little rule to remember, and then we'll just move right on to synthetic division. All right, so we got three things you're going to check off here. The first thing is that you have to be able to determine the remainder of a division problem without using long division. So that's what this says right here. So I'm going to show you today how to determine what the remainder be without even using long division if you can observe the value by seeing the graph. You can evaluate a polynomial for a given input by using long division. So you'll be able to evaluate something by just using division and observing the remainder. And you can determine whether or not a binomial is a factor of a polynomial using long division. So these three things right here, these are the things you're going to want to check off today. So we'll start off with the first example. It's saying to evaluate this using long division. And in the past, what you would do is you would just say, well, if I want to know what f of x is, and I know that now x is -2, that's just going to mean to plug in a -2 everywhere that I see an x, right? And you'd eventually multiply that out and get an answer. I'm going to show you today that there's another way to do that that does not involve evaluating it in that way. We're using the remainder theorem to evaluate it. So what you're going to do first, you're going to take -2 and turn that into the factor x plus 2. So just like we've done with roots in the past, we don't necessarily know that this is a root, but we're going to take the number -2 and turn it into a factor that we can divide by, which is x plus 2. And then we just have to use division. We're just going to do x to the 4th plus 0x to the 3rd minus 2x squared plus x minus 2. Notice that I held the place of that x cubed term with this 0x cubed, because if you're missing a term and you're just counting the exponents as they descend in order, I'm missing a 3 here, so I need this x cubed term. All right, let me put in my dotted lines to separate my terms. And now we're just using long division, which you guys should be pretty good at. We've practiced it a ton over the last weekend, so we're going to check, see how many times does x go into x to the 4th. That's x to the 3rd times. And again, last time I'll do this, but if you want to check that, you're wondering how many times does this number go into this number? So what completes this statement? And that would be an x cubed. Okay? Then x cubed times x cubed times 2. Now we have to subtract x to the 4th minus x to the 4th, 0x cubed minus 2x cubed, bring down the -2. All right, the next time through, and another time through, and finally one last time through. And now you're done with the division. Now normally, when you do long division, you would write your answer out. You'd put your plus 4 over x plus 2. Your answer here is not all this stuff. That's not your answer. The question is just saying to evaluate f of x using long division. All you've done is plug in this factor, or this binomial that you are testing to see if it's a factor, and divided by it, and your remainder is 4. So by the remainder theorem, now that you've done that long division, you can say that since f of x divided by x plus 2 gives you a remainder of 4, f of -2 is 4. And this is not the most efficient use of the remainder theorem. We're going to use it backwards more often than we're going to use it this way. But you have to get used to seeing it this way in order to get good at it using it the other way. All right? So let's try another one. And before we move on to another example, if I were you, I may make a note here to say that the remainder theorem is you can evaluate a function using long division by turning the x value into a factor, and whatever the remainder is, that's f of that x value. And I do pause and then write things because it would just be a lot of you watching me write all of the steps and all of the words. So you're using a video, you can pause and see where the steps came from or see all that stuff just so that the video isn't too long. But you should be able to pause and rewind and all that if you're really wondering where all the steps came from over here, or you could stop and pause to rewrite all that because I do understand that it just appeared on your screen pretty quickly. All right, let's do B. Same thing. Now you've got g of x, and you want to evaluate it for g of 1. So we're going to take 1 for B, just a note. I'm going to take 1, I'm going to turn it into a linear factor, x minus 1. So that's what I'm going to divide by. Okay, so I want to do 2x cubed plus 0x squared minus 2x plus 2 divided by x minus 1. All right, I'm going to put in my dotted lines. And now I'm going to run through it the first time here. Okay, now I'm going to see how many times x goes into 2x squared and run through it. Okay, now how many times does x go into 0? That's going to be 0 times. It's going to give me a 0. Negative 1 times 0 is 0 minus. So I will have a 2 as my remainder. So g of 1 is equal to 2 because that's the remainder when I divide g of x by x minus 1. Last one here, we'll do C. All right, x goes into x to the 4th, x cubed times. And notice that I did hold these places all with zeros. All right, that's pretty important. X cubed times x is x to the 4th. X cubed times negative 2 is negative 2x cubed. Subtracting. Get 0 here. We'll get a positive 2x cubed here. Bring down the plus 0x squared. All right, let's do it again. And again. And again. And therefore, because h of x divided by x minus 2 gives you a remainder of 4, h of 2 is equal to 4. Now, if any of you does not believe me and you would like to go check this in Desmos, do it. Go ahead. You got plenty of time. You can make sure you just plug in x to the 4th minus 6x, and then go see. Run the cursor right along the function until you get to 2 and see, are you at 4? Is the y value 4? And it is. You'll see that it is. All right? So you'll complete the rest of the back of this in class really quickly. Shouldn't take too long. And then your homework is going to be to do another set of these notes for synthetic division. All right? Good luck, guys. See you tomorrow.